A grey dawn breaks over the fields of Normandy. The air is thick with the scent of oil, mud, and cordite. Along a hedgerow, a British Cromwell tank idles restlessly, its Merlin-derived Meteor engine snarling, coughing, vibrating through the steel hull. Inside, the crew sits in tense silence. Sweat drips, hands tremble, and radios hiss with garbled commands. They've been ordered forward. Again. The tank lurches, treads grinding through the churned earth. Within minutes, the chatter begins. A clank in the gearbox, a burst of smoke from the exhaust. Another Cromwell stalls ahead, black fumes curling into the morning mist. The British formation slows, confusion spreading through the columns. Across the same horizon, a column of American Shermans rolls on. Smooth, steady, and endless. Their engines hum in rhythm, mile after mile, town after town. Their supply lines unbroken, their steel never resting. In that quiet contrast, one truth begins to emerge. Britain's prized Cromwell was fast but fragile, brilliant yet brittle, while America's Sherman became the machine that simply refused to stop. And behind that difference lay not just engineering, but two entirely different philosophies of war. To understand why Britain's Cromwell tank struggled and why America's Sherman endured, we must go back to the early years of the Second World War, when both nations faced the same question. What makes a tank truly effective in modern war? When the war erupted in 1939, British tank doctrine was still bound to the logic of the First World War. The British Army divided tanks into two rigid classes: infantry tanks and cruiser tanks. Infantry tanks, like the Matilda II, were built to crawl alongside foot soldiers, slow but heavily armored. Cruiser tanks, on the other hand, were meant to race ahead, exploit breakthroughs, and strike deep behind enemy lines. The idea sounded brilliant on paper, but on the battlefield, it created a mechanical and logistical nightmare. Each class needed different parts, different engines, and entirely separate maintenance systems. British industry, already stretched by the Luftwaffe's raids and material shortages, couldn't sustain that complexity. Factories were scattered, and coordination between design teams was often bureaucratic, slow, and divided by rivalry. By the early 1940s, British tank crews had seen enough. In France in 1940, and later in North Africa, they learned that speed alone was not survival. Tanks broke down before they reached the front. Gearboxes failed, suspensions collapsed, and engines overheated in desert heat. Crews nicknamed some early cruisers mobile coffins. The failures weren't about courage. They were about design philosophy. The British answer came in 1942, the Cromwell, powered by the mighty Rolls-Royce Meteor engine. Derived from the legendary Spitfire's Merlin, the Cromwell promised a revolution. It was fast, reaching nearly 40 mph, and its low profile made it sleek and aggressive. To the engineers, it was a masterpiece. To the army, it was the long-awaited solution. But beneath its polished performance, figures lay deep flaws. The Cromwell's high speed often came at the cost of reliability. Its Christie suspension was advanced but temperamental. The gearbox was prone to failure under stress. And unlike its American counterparts, it was never standardized. British factories produced multiple sub-variants with slight changes, which made spare parts a logistical nightmare. The heart of the problem was philosophical. Britain built the Cromwell as a thoroughbred, fast, elegant, but fragile. The Americans, observing from across the Atlantic, saw tanks differently. To them, the tank was not a duelist's weapon. It was a tool of mobility and endurance. A tank's strength was measured not by its top speed or armor thickness, but by how far it could go without breaking. This difference was already visible by the time of Operation Torch in 1942. British and American forces fought side by side in North Africa. The British Crusader and early Cromwell prototypes demanded constant repairs, while the American M4 Shermans kept rolling with fewer breakdowns and simpler maintenance. To a weary tanker in the desert, reliability was not an abstract concept. It was life or death. British engineers understood the problem, but faced a brutal constraint: resources. Britain's wartime industry was bombed, fragmented, and limited in steel and rubber supplies. Rolls-Royce's Meteor engines were prioritized for aircraft first, leaving the tank program struggling for enough units. Meanwhile, the Americans had industrial abundance. Detroit's production lines could deliver thousands of identical tanks, each part interchangeable from one factory to another. In 1943, as Cromwell's began to reach combat units in larger numbers, optimism grew. Crews admired its speed and maneuverability. It could outrun many German panzers on open terrain. But when the tank had to sustain days of operations, its weaknesses showed. The transmission's limited torque made hill climbs difficult. The steering system demanded constant maintenance, and if one component failed, finding replacements in the field was almost impossible. In the workshops of the Royal Armoured Corps, mechanics began to dread the Cromwell's maintenance charts. A single gearbox replacement could take days, sometimes requiring parts from multiple damaged tanks just to make one work again. Every mile driven was a gamble. Still, to the British command, it was their best option. The Cromwell would spearhead the armoured divisions in the coming liberation of Europe, while the Americans would bring their Shermans, mass-produced, standardized, and brutally simple. The stage was set for a comparison that would unfold not in the laboratories of engineers, but across the fields of Normandy and the villages of France, where two visions of warfare would be tested side by side. Across the Atlantic, the United States approached tank design with a mindset born from industrial confidence and logistical foresight. Unlike Britain, America had not been invaded, bombed, or rationed to exhaustion. Its factories stood untouched, humming with the energy of an economy built for mass production. When U.S. engineers set out to design the M4 Sherman, they were not chasing perfection. They were chasing consistency. In 1941, American military planners faced a crucial question. How do you build a tank that can fight anywhere? In deserts, jungles, or frozen plains, and still be repaired by a field mechanic with basic tools? The answer was simplicity. The Sherman was not the fastest tank on paper, nor the heaviest. Its 75mm gun was considered modest compared to German Tigers or Panthers. But its engineering philosophy was radically practical. Every part could be swapped, repaired, or replaced within hours. Its engine, whether a radial Continental, a Ford V8, or a diesel variant, was built for endurance, not refinement. Each Sherman rolled off the line identical, no matter the factory. Bolts, treads, wheels, transmissions, all standardized. A tank crippled in Tunisia could be repaired using parts from one built in Michigan. This interchangeability was the foundation of what the Americans called logistical warfare. While Britain's armored doctrine still revolved around specialized vehicles, each with a unique purpose, America chose one tank to do it all. The Sherman was a balance, fast enough to move with infantry, light enough to ship by sea, and reliable enough to march thousands of miles without an overhaul. And when it came to production, the numbers told their own story. Between 1942 and 1945, the United States produced over 49,000 Shermans. Britain, by comparison, built only around 4,000 Cromwells. The difference wasn't just quantity, it was strategy. America didn't want the perfect tank. It wanted an army of good tanks that could keep moving when everything else broke down. In the field, that philosophy saved lives. American crews learned to trust their machines. If a Sherman threw a track, they knew how to fix it. If an engine overheated, there were spares waiting in the next convoy. Even when German 80mm guns tore through their armor, the Sherman's dependability allowed the Allies to recover, repair, and rejoin the fight within days. British units, on the other hand, were forced to adapt to constant maintenance delays. Reports from the Normandy campaign describe entire Cromwell squadrons halted for repairs. Gearboxes stripped, cooling systems ruptured, engines misfiring. The Meteor engine, while powerful, was notoriously sensitive to dust and debris, conditions common in France and Holland. Meanwhile, American tank battalions covered hundreds of miles in coordinated thrusts, from Normandy to Paris, and later from Belgium to the Rhine. Their tanks didn't just fight, they moved. And movement was victory. Even British officers began to take notice. General Bernard Montgomery, initially skeptical of American equipment, came to respect the Sherman's reliability during combined operations. The British Army adopted several Sherman variants, even modifying them into the Firefly. Armed with the formidable 17-pounder gun to counter German armor, it was a quiet acknowledgement. The Americans had built something that simply worked. But to British engineers, this was bittersweet. The Cromwell was meant to be a symbol of national pride, a sleek racing stallion compared to the Sherman's plodding workhorse. Yet, as the war dragged on, it became clear that elegance could not compensate for endurance. Tanks that couldn't stay operational became liabilities, no matter how well they performed in short bursts. By 1944, British industry was already pivoting, designing the Comet, a refined evolution of the Cromwell with better armor and a more stable gun platform. But the Comet arrived late, its lessons learned through hard experience and broken gearboxes scattered across Europe. As the Allies prepared for their great push into Germany, one contrast defined their armored forces. Britain's tanks looked fast, but rarely stayed running. America's tanks looked ordinary, yet kept moving, hour after hour, mile after mile, from the beaches of Normandy to the heart of the Reich. That unstoppable endurance would soon become legend. Symbol of how industrial simplicity could triumph over mechanical ambition. And as the Allied columns rolled east, those two tanks, the Cromwell and the Sherman, would face their greatest test on the battlefields of France and Germany. Every war machine tells more than a story of steel and gears. It tells the story of the people who rode inside it, the hands that maintained it, the minds that designed it, and the soldiers who trusted it with their lives. The Cromwell and the Sherman were no exceptions. Their differences were not just mechanical, they were human, psychological, and cultural. For British tank crews, the Cromwell was both a source of pride and a daily struggle. When the tank first entered service in 1943, its speed and low profile impressed its operators. It could sprint across open ground faster than any Allied tank, earning nicknames like the racing tank. But that pride often turned to frustration. Crew diaries from the 7th Armored Division describe long nights repairing jammed transmissions and overheating engines. Mechanics worked under shell fire, covered in oil, trying to coax the Meteor engine back to life. Every time a Cromwell stalled mid-maneuver, it wasn't just a technical failure. It was a moment of fear. In war, immobility meant death. American tank crews, by contrast, learned to trust their Shermans. Their machines weren't glamorous, they were practical. The Sherman's engine usually started on the first try. Its suspension handled rough ground smoothly, and its roomy interior gave crews space to move, reload, and even survive a hit. Many veterans later said they loved their Shermans, not because they were invincible, far from it, but because they could depend on them to get home. Reliability became a kind of morale. In long campaigns, when exhaustion and fear could erode the will to fight, knowing your tank would start every morning mattered more than any technical advantage. British crews, meanwhile, often watched American units advance while they waited for recovery trucks or spare parts. It wasn't just a difference in machines, it was a difference in momentum. The Cromwell and Sherman were born from entirely different doctrines of War Britain's design philosophy still carried echoes of the Great War. Its armored warfare doctrine divided roles sharply: infantry tanks for slow assaults, cruiser tanks for high-speed breakthroughs. That meant every design was a specialist tool, optimized for one task and one environment. In theory, it gave commanders flexibility. In practice, it created confusion, especially in the chaos of mobile warfare. The Americans saw tanks as generalists. For them, a tank had to fight in any terrain, support infantry, and exploit breakthroughs all in one. This simplicity wasn't just about design, it was about strategy. American doctrine emphasized mechanized momentum. Every tank, truck, and jeep had to move in harmony, sustained by vast supply lines stretching from Normandy's beaches back to the ports of Britain. A tank that broke down often wasn't just a mechanical inconvenience. It broke the rhythm of the entire advance. That's why, during the Normandy campaign, American armored columns could push deep into France, while British units were forced to halt for refits. The Sherman's mechanical consistency allowed the U.S. Army to maintain an almost unbroken tempo. British commanders recognized the problem, but were trapped by circumstance. Their industry couldn't mass-produce a single design to match America's scale. Every Cromwell division had slight differences, and every breakdown demanded improvisation. Mechanics learned to scavenge parts from wrecks, cannibalizing damaged tanks just to keep others running. The difference between doctrine and delivery was becoming painfully clear. Britain built for speed and firepower, but America built for endurance and flow. Beneath the armor plates and engines lay something deeper: national identity. For Britain, the Cromwell was a matter of pride. It was the first tank designed entirely without American assistance, powered by a homegrown engine derived from one of the nation's most celebrated inventions, the Rolls-Royce Merlin. To scrap or criticize it felt unpatriotic, but by 1944, even high command could not ignore the reports. Units in France complained of chronic unreliability. Spare parts were running short. Field commanders began requesting American Shermans instead. For British industry, it was a humiliation. The realization that the pragmatic, unrefined American tank had outlasted their elegant design. Across the ocean, American engineers were proud of something else: functionality. They didn't care if their tanks were criticized for being ugly or undergunned. They cared that they worked. Every factory worker in Detroit, every assembly line manager in Chicago shared that philosophy. Build it, ship it, make it easy to fix, and let the soldier finish the story. By the time Allied forces reached France in mid-1944, this divide in philosophy had hardened into reality on the battlefield. Cromwells were admired in parades, sleek, fast, photogenic. But Shermans were the ones grinding through the mud, pulling other tanks out of ditches, and reaching objectives no one thought possible. The contrast between these two machines, and the cultures that created them, would soon reach its most brutal test in the heart of Normandy, where every weakness would be exposed under fire. On paper, the Cromwell had everything a commander could want. It was fast, with a top speed of over 40 miles per hour. Its Meteor engine, adapted from the legendary Rolls-Royce Merlin that powered the Spitfire, gave it unmatched acceleration for a medium tank. The Christie suspension allowed it to glide over uneven terrain, theoretically perfect for rapid maneuvers and flanking strikes. Yet in war, theory rarely survives contact with reality. The same Meteor engine that gave the Cromwell its speed also made it notoriously difficult to maintain. It required precise tuning, frequent servicing, and clean fuel. Luxuries rarely available on the battlefield. The gearbox, designed to handle less power, struggled under the Meteor's torque. Crews complained of constant clutch failures and transmission breakdowns, especially during long marches or sharp turns. And unlike the Sherman, no two Cromwells were truly alike. Different factories used slightly different fittings, parts, and even armor configurations. A spare part from one production batch wouldn't always fit another. This lack of interchangeability crippled field repairs. A British maintenance unit might have spare components on hand, only to discover they didn't match the tank in need. The Sherman, by contrast, was an engineer's triumph of industrial discipline. Every bolt, track link, and engine part was standardized across all variants. The tank could be stripped, repaired, and reassembled by crews with minimal training. Even its engine compartments were designed for accessibility. Panels could be removed quickly, and major components swapped within hours. That's why American armored divisions could conduct long-distance thrusts, like the 2,000-mile advance from Normandy to the Elbe, with far fewer breakdowns. Every Sherman was not just a fighting machine, it was part of an ecosystem of reliability. The Cromwell was fast and beautiful, but it was a racing machine trapped in a marathon. The battlefields of Normandy, 1944, were not kind to the Cromwell. Its low silhouette and speed made it an excellent reconnaissance and support tank. But in the bocage country, dense hedgerows, soft ground, and narrow lanes, speed became meaningless. What mattered was mechanical stamina and ease of repair. British armored units reported frequent stoppages due to overheating engines and transmission strain from constant gear changes in tight, uneven terrain. The Sherman, with its more forgiving powertrain, adapted better. Its wide tracks and stable suspension allowed it to navigate mud and rubble without overexerting its engine. American crews developed a simple rhythm: advance, maintain, refuel, move again. Each Sherman crew was trained not just to fight, but to repair. Field maintenance was part of the doctrine. The Cromwell crews didn't have that luxury. Their tanks required specialists, and spare parts often came days later, leaving entire squadrons immobilized. This difference in operational rhythm was decisive. An army that could keep its armor moving, even imperfectly, always held the initiative. When the British Cromwell units paused for maintenance, the American Shermans simply kept driving. The Germans could never fully regroup because the Americans never fully stopped. In essence, the Sherman was a weapon of continuity. It may not have been the strongest, but it was always there, pushing forward, linking fronts, keeping pressure constant. Behind every tank was a supply chain, and in that, America's strength was unmatched. By 1944, U.S. logistics operated like a living organism. Replacement engines, transmissions, and even entire Sherman hulls were shipped across the Atlantic and distributed with mechanical precision. Tanks were repaired and returned to service in days, not weeks. Britain simply couldn't compete on that scale. Its factories, often bombed or overworked, couldn't sustain the flow of parts needed to support thousands of tanks across multiple fronts. The Cromwell's maintenance demands drained manpower and fuel, resources Britain could ill afford. The Sherman, by contrast, was designed for supply over sophistication. Its armor could be welded by civilian factories, its tracks replaced by basic workshops. Every decision, from the size of its bolts to the layout of its hatches, was made to favor mass repairability. This wasn't just engineering, it was strategy. The U.S. Army knew that wars are not won by the most advanced machines, but by the ones that can fight every single day. And so the Sherman became less a tank and more a system of movement, the beating heart of Allied offensives from Normandy to the Rhine. The Cromwell story, meanwhile, became a cautionary tale that brilliance in design means nothing if it cannot endure the grind of war. As the summer of 1944 turned into autumn, that lesson would be carved into the muddy fields of France. When the Allied advance reached its decisive phase, and both tanks were pushed to their absolute limits. Normandy, July 1944. The sun rose through a haze of smoke and dust over the plains east of Caen. The Allied advance was grinding forward, village by village, against entrenched German resistance. It was here, during Operation Goodwood, that Britain's Cromwell would face its harshest trial, and the Sherman would prove why it was the backbone of the Allied war machine. The British plan was bold. 3 armored divisions, over 1,000 tanks, would surge east of Caen to break through German lines. The terrain looked ideal for a fast tank like the Cromwell. Flat fields, long sight lines, open country. To the crews of the 7th Armored Division, this felt like the chance to finally unleash the speed their tank was built for. But reality struck before the first hour of battle was over. The advance began under a thunderous Allied bombing campaign. The ground shook, dust and smoke filled the air, and visibility dropped to near zero. As the Cromwells moved through the shattered villages, the choking dust clogged radiators and air filters. Engines overheated. Gearboxes jammed. Some tanks halted within the first few miles. Not from enemy fire, but from their own mechanical strain. Tank commander reports describe the scene. Engines running hot. Loss of oil pressure. Vehicles stopped. For a tank that promised 40 miles per hour, the Cromwell was now struggling to make 5. As the formation slowed, German anti-tank guns, dug in and waiting, opened fire. The Cromwell's thin armor, especially on the sides and rear, was easily penetrated by 75mm and 88mm shells. Tanks burned across the open fields, their speed useless against well-placed ambushes. Those that survived withdrew, not because of cowardice, but because their machines simply couldn't endure the sustained pace. At the same time, American forces to the west, supported by their Shermans, were moving with quiet, relentless momentum. The M4s didn't look impressive on paper, but they did what mattered most. They kept moving. From Saint-Lô to Avranches, Sherman columns advanced through cratered roads, hedgerows, and wreckage. Where British units paused for repairs, the Shermans pressed on, refueling, resupplying, and repairing in the field. The difference in engineering philosophy had now become visible in the mud of Normandy. The Cromwell was a sprinter in a marathon. Its crews fought bravely, but the machine's limitations turned every engagement into a race against mechanical failure. Meanwhile, the Sherman's crews could count on reliability, predictability, and the massive logistical machine behind them. Even within the British Army, the contrast was impossible to ignore. Some units began replacing their Cromwells with Shermans, not because they preferred American design, but because they needed tanks that could survive the pace of war. Mechanics found the Sherman easier to service, easier to understand, and far less temperamental. British war diaries from the period are filled with quiet frustration. One entry reads, "The Cromwell moves well on exercise, but in battle, it punishes its crew. We fix one fault, another appears." The Meteor engine, magnificent in theory, became a burden under real conditions. Dust, mud, and long-distance marches exposed every weakness that design pride had hidden. Meanwhile, in the same campaign, American tank battalions were executing a feat few thought possible. A continuous 2,000-mile drive through France and into Germany. The Shermans didn't do it quickly, but they did it without breaking. Their simplicity was their strength. A Sherman could lose a track, blow a gasket, or take a glancing hit, and still keep going after field repairs. For U.S. engineers, this was the validation of everything they believed. The war was not about perfect machines. It was about machines that could fight again tomorrow. During Operation Goodwood, more than 400 British tanks were damaged or destroyed. Many were repairable, but dozens were lost not to enemy fire, but to mechanical exhaustion. The German defenders were amazed. They had expected the British tanks to withdraw under fire, not collapse under their own design strain. To the British command, it was a sobering lesson. The Cromwell's limitations were no longer theoretical. They were written in burnt-out hulls across the fields of Normandy, and in the chaos of battle, one truth had become undeniable. The Sherman's steady heart had outlasted Britain's mechanical ambition. But this was only the beginning. As the Allied advance deepened and the long push into Europe began, the difference between endurance and fragility would decide who could keep moving, and who would be left behind on the side of the road. The roads to Paris were choked with dust, wreckage, and triumph. The German front had finally broken, and Allied armor, British, Canadian, and American, was surging eastward in pursuit of a retreating enemy. But in the long columns rolling through the French countryside, one pattern was impossible to miss. The British Cromwells were thinning out. The American Shermans were everywhere. To the soldiers on the ground, the reason was obvious. The Cromwell could fight. No one doubted that. But it could not endure. It demanded constant care, constant tinkering. A single long march could undo a week's worth of preparation. Crews joked bitterly that the Cromwell was a racehorse made to pull a plow. In contrast, the Sherman seemed almost indifferent to hardship. Its tracks chewed through mud, rubble, and broken roads. Mechanics could fix one with basic tools in a farmyard. If a Sherman broke down, it wasn't abandoned. It was patched, fueled, and back in the line by nightfall. American tank units were advancing over 30 miles a day. British armored divisions, using Cromwells, often had to pause, not for fuel or ammunition, but because too many tanks had overheated, thrown tracks, or lost oil pressure. The difference wasn't in bravery or training, it was in design. The Cromwell was the product of British perfectionism. A tank designed to match German engineering, to outpace and outmaneuver the Panzer IV. It was fast, elegant, and sleek, but the battlefield punished elegance. The Sherman, by contrast, was built on American pragmatism. Its engineers asked one question: can it be mass-produced, maintained in the field, and survive long enough to fight again tomorrow? So while the Cromwell strained under the weight of its own ambition, the Sherman thrived under simplicity. Its gearbox was smoother, its suspension more forgiving, and its engine less temperamental. A Sherman could run for thousands of miles, not because it was perfect, but because it was built to tolerate imperfection. In one report from the U.S. Third Army, a Sherman column completed a 2,000-mile advance from Normandy to the German border without a single catastrophic mechanical failure. Crews changed oil on the move, replaced filters in the mud, and drove day and night. It wasn't glamorous, it wasn't heroic, but it was relentless, and it won wars. On paper, the Cromwell's top speed was 40 miles per hour, far beyond the Sherman's modest 25. But no tank ever fought on paper. In France's countryside, where roads were broken and villages smoldered, speed was meaningless. Tanks moved at convoy pace, 5, maybe 10 miles per hour. The Cromwell's engine howled and overheated at those speeds. Its track tension loosened. Its high profile made it a target. A tank commander from the 11th Armored Division wrote in his diary, "The Cromwell moves beautifully on a parade ground. In France, it feels like driving a stallion through a swamp." Meanwhile, Sherman crews joked that their tanks had the soul of a tractor. But that tractor's soul kept going. Through shellfire, through ambushes, through every mile of France, Cromwell crews knew they were fighting in a tank that could betray them. Every rattle, every rise in temperature was a reminder that their machine might give up before they did. Sherman crews, though facing their own fears, especially against German Tigers, had something the British often lacked: trust in their machine. They knew it would start in the morning. They knew it could take punishment and still roll forward. That confidence changed everything. In the chaos of combat, when shells screamed overhead and radios crackled with panic, the trust in their tank gave them seconds. Seconds that decided whether they lived or died. By late 1944, Allied logistics officers began to see the effect on a larger scale. The Cromwell's breakdowns slowed entire columns. Supply convoys had to stop for stranded tanks. Recovery units were overworked. Mechanics were exhausted. By contrast, Sherman formations advanced with near-mechanical rhythm. Even when individual tanks were lost, replacements arrived faster than they could be destroyed. It was a system designed for continuity, something the Cromwell's designers had never fully accounted for. The British Army's high command began to accept what was once unthinkable, that America's average tank had become history's most successful one. And so, even as Britain introduced newer designs, the Comet, and later the Centurion, the shadow of the Sherman loomed large. The Cromwell, once Britain's hope for armored supremacy, had become a stepping stone. It was not a failure of courage or ingenuity. It was a failure of philosophy. Britain had built a tank for performance. America had built a tank for persistence. And in the long, brutal race across Europe, persistence always won. As the war rolled toward its end and Allied armor pushed into Germany, the Cromwell story was nearly complete. Crews who had once believed in its promise now looked at their battered machines with mixed emotions. Pride, yes, but also exhaustion, because by then, everyone on the Western Front knew the truth. Speed, firepower, and design meant nothing if your tank couldn't last the journey. And, for 2,000 miles, through mud, fire, and ruin, the Sherman had proven it could. Autumn came with cold rain, gray skies, and endless mud. Allied momentum slowed. Roads dissolved beneath the weight of armor, and every advance felt like a struggle against nature itself. It was here, amid flooded fields and ruined villages, that the Cromwell's true limitations were laid bare. A column of British tanks from the Guards Armored Division moved toward Eindhoven during Operation Market Garden, a desperate push to cross the Rhine before winter. The Cromwells led the way, their sleek forms glistening under the rain. But within hours the mechanical chorus began. Coughing engines, failing clutches, leaking radiators. By nightfall, several Cromwells were abandoned in ditches, their crews seeking shelter beside them. Meanwhile, just miles away, American Shermans of the 2nd Armored Division pressed on relentlessly. They weren't immune to damage. Some burned, others bogged down. But the difference was unmistakable. For every Cromwell left behind, a Sherman found a way forward. To the men watching from the mud, it wasn't a matter of pride anymore. It was survival. The British High Command had known for months that the Cromwell wasn't built for the long haul. Reports from field workshops were piling up. Gearboxes failing, road wheels cracking, engines overheating after sustained marches. But war doesn't pause for redesigns. The tanks that existed were the tanks that had to fight. And so, in battle after battle, the Cromwell was pushed beyond its limits. The crews compensated with ingenuity, using captured German fuel drums, scavenging spare parts, even cannibalizing one tank to keep another running. They fought not just the enemy, but their own machine. The Sherman, by contrast, needed no miracles. It was designed for war's chaos. Its interchangeable parts meant that a wrecked tank could become a donor for another within hours. Its engine, whether radial, diesel, or Ford GAA V8, could run dirty, under stress, with minimal maintenance. In one recorded incident near the Belgian border, a Sherman battalion completed a 200-mile pursuit of retreating German forces in just 4 days, through mud, rain, and craters. The Cromwells assigned to support the flanks fell behind after only 60 miles. The difference was no longer technical. It was psychological. Ask any British tanker in late 1944 what they thought of their Cromwell, and you'd hear the same two emotions, affection and frustration. They admired its speed when it worked. They trusted its armor, to a point, but they feared its unpredictability. Every long march was a gamble. Every stop, a moment of anxiety. Will it start again? American crews, though never blind to the Sherman's weaknesses, had something far more valuable: predictability. They knew the tank's limits and its strengths, and both were consistent. A U.S. tank commander from the 3rd Armored Division recalled, "You didn't have to pray for the Sherman to run. You just had to fuel it and go." For British soldiers watching columns of Shermans thunder eastward, that reliability became a kind of envy. One British officer, writing from the Netherlands in October 1944, confessed in a letter home, "The Yanks' tanks keep moving when ours would rather rest. It's as if theirs were made for war, and ours for demonstration." By early 1945, the Allies were closing in on the Rhine. Germany was collapsing, but it was also fighting with desperate ferocity. Bridges were destroyed, towns fortified, and the winter cold was unforgiving. This was the moment when every machine, man or metal, was tested to its limit. In February, the British 7th Armoured Division, the famed Desert Rats, entered the Rhineland with their Cromwells. The terrain was brutal: boggy fields, minefields, wreckage everywhere. The Cromwell's high speed was useless. Traction and torque were everything. Tanks sank, engines flooded, and transmissions cracked. Meanwhile, General Patton's Third Army, spearheaded by hundreds of Shermans, advanced nearly 100 miles in 10 days. Shermans crossed rivers on improvised bridges, drove through forest tracks, and kept pressure on the retreating Wehrmacht. When they reached the Rhine, they had driven more than 2,000 miles from Normandy, most on original engines. The Cromwell had been fast. The Sherman had been unstoppable. In the final months of the war, British designers finally introduced the Comet, a refined, more reliable successor to the Cromwell, with better suspension and a 77mm gun. It was everything the Cromwell wanted to be, and what the Sherman already was. But for the men who had lived through 1944, the lesson had already been learned the hard way. They realized that the future of armored warfare wouldn't be decided by elegance or horsepower, but by endurance, logistics, and adaptability. The Sherman had proved that a good enough tank, multiplied by the thousands, could crush any empire that relied on perfection. As the British watched American armor roll eastward into Germany, still running, still fighting, still moving, there was no shame, only respect. The Cromwell had fought bravely, but the Sherman had endured history. In the end, the war didn't remember the tank that was fastest. It remembered the one that never stopped moving. The Cromwell became a lesson in ambition. The Sherman became a symbol of resilience, and in the silence after the guns fell quiet, the difference between the two was carved not in steel, but in miles. The war in Europe was over. Allied flags fluttered over shattered cities. Burnt-out tanks, German, British, and American, lined the roads like iron gravestones marking the path to victory. For the crews who had survived, the silence was almost unbearable. Engines that had once growled day and night were now cold. The smell of oil, exhaust, and burnt steel lingered like ghosts of a war that had consumed everything. Among those hulks, the Cromwell and Sherman stood side by side, two very different machines that had fought the same enemy but told two very different stories. The Cromwell had been Britain's symbol of ingenuity and determination. It had raced across Normandy, fought in Holland, and reached into Germany itself. But it had done so with scars. Countless mechanical failures, endless hours of maintenance, and far too many tanks left behind for reasons that had nothing to do with enemy fire. The Sherman, on the other hand, had carried its crews across 2,000 miles of Europe without surrendering to wear or fatigue. It had been damaged, repaired, rebuilt, and sent back again and again, and in that endurance lay the secret to Allied victory. Historians often argue that the Sherman wasn't the best tank of the war, that the German Panther or Tiger outclassed it in firepower and armor. But those who fought the campaign knew the truth. A tank that runs is worth more than one that waits. The Sherman's mechanical simplicity was its greatest weapon. It could be mass-produced, transported, and maintained anywhere in the world. American logistics delivered engines, gearboxes, and even entire turrets faster than the enemy could destroy them. Cromwell crews, meanwhile, worked with a fraction of that support. British industry, strained by years of bombing and smaller resources, couldn't match American volume. Each new tank was precious, and every breakdown was a small tragedy. By the war's end, more than 49,000 Shermans had rolled off assembly lines. A staggering feat of industrial power. The Cromwell's production never crossed 4,000. That imbalance changed the very shape of the war. When Allied armor surged into Germany, it wasn't the best tank that won. It was the one that was always there. In the aftermath of victory, British engineers gathered to study what had gone wrong. Reports from the field told a clear story. The Cromwell's Meteor engine was powerful but fragile under long strain. The suspension system wore down quickly on rough terrain. The armor layout made maintenance difficult. Its high speed, once celebrated, offered little advantage in real combat. There were also strategic lessons, sobering ones. The British had designed the Cromwell with performance over endurance, believing that speed and precision would overcome quantity. But the war had exposed a different truth. A tank's greatest weapon was not its gun or engine. It was its ability to keep moving under any condition. So when post-war planning began, the Cromwell's philosophy was quietly abandoned. In its place came the Comet, and then the Centurion, tanks that emphasized balance, reliability, and battlefield survivability. The British had learned, painfully, but permanently. Across the Atlantic, American factories were already dismantling their production lines, converting from war to peace. But the Sherman's legend was cemented. It had fought in every theater, Europe, Africa, Asia, and the Pacific, under every condition imaginable. It had served in the U.S., Britain, the Free French, Poland, and the Soviet Union. And as the world looked at the outcome of World War II, one conclusion stood out. Industrial reliability had defeated mechanical sophistication. Every Sherman that kept rolling made up for 100 design compromises. Every Cromwell that broke down, no matter how advanced, weakened its formation. That lesson reshaped post-war doctrine on both sides of the Atlantic. The next generation of tanks, from the Centurion to the American Patton series, were built not to dazzle engineers, but to serve soldiers. Because when the world went to war again, nations remembered what 2,000 miles of marching steel had already proved. A machine that endures outlives a machine that excels. The Cromwell had not been a disaster. It had been a teacher, a flawed but vital chapter in the evolution of the modern tank. One that showed how the pursuit of perfection could be undone by the lack of simplicity. And though its roar faded with the war's end, its legacy endured, carried forward by the tanks that came after, all built upon the same hard-earned lesson. The war was over, but the machines remained. Across the continent, fields once filled with fire were now filled with wrecks. Rusting hulls of Tigers, Panthers, Cromwells, and Shermans lying side by side in silent equality. The war had ended their rivalry, but it had not ended their story. In depots from Antwerp to Hamburg, Allied engineers began the long work of salvage and study. Some tanks were melted down. Others were repaired and sent to new nations rebuilding their armies. The Cromwell, though outdated, found a quiet second life in training battalions and smaller European forces. The Sherman, meanwhile, began a career that would outlive nearly every tank of its generation. From the deserts of Israel to the hills of Korea, the Sherman rolled again, sometimes upgraded, sometimes battered, but always reliable. It had become more than just a wartime vehicle. It was now a symbol of endurance, a reminder that design rooted in simplicity could transcend time. The Cromwell did not enjoy the same afterlife. Its flaws were too deep, its maintenance too demanding, its role overtaken by better designs. Within a decade, it disappeared from frontline service, replaced by the Centurion, a machine born from the lessons of its failure. In the quiet years after the war, British and American engineers met to exchange studies. They compared everything: engines, suspensions, armor angles, even the stress fractures on recovered hulls. Their findings revealed the essence of wartime success. The Cromwell had been an engineer's dream. Refined, complex, but unforgiving. The Sherman had been a soldier's companion. Practical, repairable, and adaptable. Those differences shaped a new generation of design philosophy. Post-war British and American tanks emphasized crew survivability, maintainability, and global deployability. The Sherman's interchangeable parts and modular systems became the foundation for NATO standards. The Cromwell's mechanical issues became case studies in overspecialization. Warnings against designing machines for ideal conditions that war never provides. As one post-war British engineer reportedly said, "The Cromwell taught us how not to build a tank. The Sherman taught us why we must never stop one." By the early 1950s, Shermans were still rumbling through the world's conflicts, in Korea, in the Middle East, even in South America. Its descendants, upgraded Fireflies, Israeli Super Shermans, and French M4A4s, became a common sight in post-war footage. Each one told the same story: a tank that refused to die. The Cromwell's influence, though quieter, survived in British design DNA. The Centurion, which entered service in 1945, was the spiritual successor that finally achieved what the Cromwell never could: a balance between power and endurance. Its success, in many ways, redeemed the British armoured legacy that had faltered in Normandy. But the war's great mechanical duel had already been decided. The Sherman had not only outlasted the Cromwell, it had outlasted the war itself. By the time the 1950s began, armies and historians alike had stopped arguing about which tank was best. They began to ask a deeper question: what does best even mean in war? For the Cromwell, best had meant speed, precision, and mechanical brilliance. For the Sherman, it had meant persistence, the ability to fight today, tomorrow, and every day after that, and history, as always, sided with endurance. Because in war, the tank that keeps moving writes the story. The one that stops, no matter how perfect, is forgotten. The Cromwell had carried the courage of its crews, but the Sherman had carried the burden of victory. One struggled to reach the front, the other became the front. By the time the last Cromwells were decommissioned, few remembered its specifications or its promises. But every soldier who had fought beside a Sherman remembered something more important: the feeling of a machine that never quit. That feeling of momentum, of dependability, of knowing that steel and man could move as one across 2,000 miles of hell, became the legacy that defined Allied armor. And so, when the last Sherman rolled to a stop in a museum yard decades later, its engines silent, its treads rusted, its story was already immortal. Not because it was flawless, but because it endured. In the stillness that followed the Second World War, the echoes of engines faded into history, but the lessons they carried did not. Steel, once molded for destruction, had become a mirror for human intention. The Cromwell and the Sherman were no longer just tanks. They were philosophies cast in metal. The Cromwell embodied ambition, Britain's drive to reclaim technological mastery, to fight with precision and speed. It was elegant, bold, and tragically over-engineered. The Sherman embodied endurance, America's understanding that war is not won by perfection, but by persistence. It was plain, durable, and utterly dependable. In the mud of Normandy and the ruins of Germany, those two ideas met, and history decided between them. Because in every war, every battle, every march through smoke and fear, it is not brilliance that endures, but reliability. Not the machine that shines, but the one that survives the miles. The Cromwell burned bright, then burned out. The Sherman kept going. That difference, a few degrees of design, a few choices of philosophy, changed the course of the Western Front, and perhaps the outcome of the entire war. And yet, both tanks, in their own way, carried the same human truth, that behind every engine's roar was the heartbeat of a crew who believed in it, who climbed into steel knowing it might fail, yet drove on anyway. Their courage outlasted the machines. Their lessons outlasted the war. Today, when we look upon those rusted relics, the Cromwell's sharp lines, the Sherman's humble frame, we are not seeing failure or success. We are seeing the evolution of endurance, a reminder that in war, as in life, it is not perfection that defines victory. It is the will and the design to keep moving forward.